Hello everyone, welcome to Robert Morris University Math 0900 Chapter 4, Lesson 4. This is Brianne Pernick. In this lesson we are going to focus on learning how to multiply polynomials. In the last lesson we learned what a polynomial was as well as how to add and subtract them. In this lesson, we are going to focus on the multiplication of those polynomials. The first method that we use for multiplying polynomials is to be able to multiply a monomial by a polynomial. And you have actually done this. We just didn't use the terminology of monomial being multiplied by polynomial. You have used this whenever you learned how to use the distributive property. During the distributive property, you have taken your monomial, which is similar to the letter A in front of your parenthesis, and distributed it into the entire parenthesis. That was not supposed to move itself over there like that. Let's get it back where it goes. And distributed that A into the parenthesis and multiplied it times the B and the C in order to simplify the entire thing. You've done this. By this point in our class, you should know how to do it with proficiency. So if not, I encourage you to go back and revisit that lesson to make sure that you do know how to distribute. What we're going to focus on now is utilizing some monomials that are more than just a number or a variable. They're going to actually be a combination thereof and be some more in-depth monomials. So example 1, we have 3x squared being multiplied by the quantity 5x minus 2. So remember that in this situation, you are going to rely on the distributive property to simplify this problem. So we're going to take the monomial of 3x squared and multiply it by 5x. That's our first step. So 3 times 5 makes 15, and x squared times x gives us x cubed. The next step that we take is 3x squared times negative 2, which is going to give us negative 6x squared. There's nothing further to this problem because we can't go any further with the simplification process. Our x cubed and x squareds are different terms, so they cannot be combined. Therefore, we can go no further. I'd like you to pause the recording and simplify example A by using the distributive property. Okay, by now you should have had an opportunity to complete example A and you should be ready to go over the answer with me. You should have distributed the 2x into that group of parentheses and multiplied it by every single term. So 2x times x squared makes 2x cubed. 2x times 3x makes positive 6x squared. And 2x times negative 1 makes negative 2x. You always check after distributing to see whether or not you can combine like terms. In this example, you have no like terms, so you can go no further than what you have done here. So this is your final answer. Please take a moment and complete example B. Whenever you are ready, please play the recording and we will check your work together. At this point, you should be ready to check your work with me. The first thing that you should have done is distributed the negative 2xy squared to each term inside our group of parentheses. So negative 2xy squared times x squared is going to give us negative 2x cubed y squared. Negative 2xy squared times negative 2xy gives us positive 4x squared y cubed. And lastly, negative 2xy squared times negative 3y squared gives us positive 6x y to the fourth. You want to check to see if you have any like terms that can be combined. In this particular problem, we do not. So this is our final answer. Example 3 is one in which the monomial is written on the right-hand side and the polynomial is written on the left. That's okay. You can either distribute backwards like this, or some people choose to rewrite their expression and put it so that the monomial is written in the front. It makes no difference which method you like. I happen to be the type of person that likes to rewrite and put my monomial in the front. I don't know why. I just like it that way. I guess I'm more of a left to right kind of person. Once you get that rewritten, if that's your preference, then you're just going to distribute as we have in every other example. So we have negative 2x cubed y, positive 4x squared y, and negative 12x y. Always check to see if you can combine like terms. We cannot, so this is our final answer. The next section is going to require us to multiply two binomials rather than a monomial and a binomial. Multiplying two binomials is going to allow us to use a process called the FOIL process, which you will notice is the one and only vocabulary word for this section. FOIL is an acronym that stands for first, outer, inner, last. And it tells us the steps in which we should multiply the terms in the two binomials. The F tells us that we should multiply the first terms together. The O tells us that we should then multiply the outer terms together. So this demonstrates the first terms in each quantity. The O stands for the outer terms. That's the two outside terms. The I is the inner terms. That's the two inside terms. And the L is the last terms. That's the two terms that appeared last in each binomial. When you follow the steps of FOIL, you have ensured that you have multiplied every single term together in that set of binomials. And then you're simply going to combine like terms and simplify in order to get a final answer. So what we're going to do now is look at a series of examples and follow the steps of FOIL. F-O-I-L. So the first thing that we're going to do is multiply the first terms in each quantity. So we want to do first times first. So that's 2x times 3x, which gives us 6x squared. Then we want to do the outer terms. The outer terms are 2x and 2. So 2x times 2 gives us 4x. Then we want to do the inner terms, which are negative 1 times 3x, which is negative 3x. And then L is last, which is the last terms in each quantity. So we have 2x times 2, which gives me a positive 4x. Oh, excuse me. That's not the right step there. 1 second. We want the last terms in each quantity. I apologize. Which is negative 1 and 2. My apologies there. Last and last. So we have negative 1 times 2, which is negative 2. My apologies there. So then you check to see if you can combine like terms. We can. So we're going to bring down our 6x squared. 4x minus 3x is positive 1x minus 2. And that is our final answer. Example 5. Just more foiling. We're going to keep practicing foiling until we are good at this. So we're going to start with first times first. 4a and 3a make 12a squared. Outers, 3a times negative b makes negative 3ab. Inners, negative 2b times 4a makes negative 8ab. And the last terms, negative 2b times negative b makes positive 2b squared. Combine like terms, we have 12a squared. Negative 3ab minus 8ab makes negative 11ab plus 2b squared. And this right here is our final answer once all like terms have been combined. Example 6, I would like for you to try on your own. Please go ahead and try this one. Please pay attention to positive and negative signs. As soon as you're finished, please press play and we will review the answer together. Okay, by now you should have had an opportunity to complete example 6 and you should be ready to check your answer with me. So following the steps of FOIL, F-O-I-L, first, outer, inner, last, the first thing that you would want to do is multiply the 3x times the 5x, which should have given you 15x squared. Then you want to multiply your outer terms. 3x times negative 3z gives us negative 9xz. Then we want to do our inner terms. 2y times 5x gives me 10xy. Then we want to do our last terms in each quantity. We have 2y times negative 3z, which gives us negative 6yz. Check to see if you have any like terms. We do not. Your variables should be written in alphabetical order within each specific term. I would check to make sure that you have done that. And once you're done, that is your final answer. Example 7, though it may look different, is actually the same type of problem. What we have here is a quantity that has been squared. Some people often say, well, all I have to do here is have 7x squared and negative 2y squared. That is not the correct way to solve this problem. If you think about the meaning of an exponent, what that exponent tells you to do is to multiply the base by itself the same number of times that the exponent represents. So what this means is that you are to take your quantity and multiply it by your quantity, because you have a quantity squared. Your quantity is your base. So if you think about what that means when you put it in expanded form, you are repeatedly multiplying that quantity by itself. So in order to correctly do example 7, you must expand it and have 7x minus 2y times 7x minus 2y. You may never, ever simply bump that exponent inside that quantity. Okay? We have to create two binomials that are being multiplied by each other and then use the FOIL process from there. So we will do our firsts, which is 7x times 7x, and have 49x squared. Our outers, 7x times negative 2y, negative 14xy. Negative 2y times 7x, which is another negative 14xy. And then we have our lasts, which is positive 4y squared. Checked for like terms. We can combine our middle terms and have negative 28xy plus 4y squared. So as you can see, that is a very different answer than what one would have gotten had they just tried to bump that exponent into the quantity. Please always remember that you must expand that out and create two quantities that you must multiply together. Example 8 is just another binomial times a binomial. Please pause the recording, complete this one on your own, and when you're ready, we will check your answers together. Okay, by now you should have had an opportunity to complete example 8, and you should be ready to check your answers with me. So using the FOIL process, we are going to review the answer here. So we should have started with 3x squared times 2x squared to get 6x to the 4th. The outers are 3x squared times 5y cubed, which should have given us 15x squared y cubed. The inners are 4y cubed times 2x squared, which gives us 8x squared y cubed. And the last terms are 4y cubed and 5y cubed, which gives us 20y to the 6th. You want to check to see if you can combine any like terms. Our two middle terms are similar, so we can go ahead and combine those. 15 plus 8 gives us 23 x squared y cubed, and lastly we want to bring down the 20 y to the 6th. We have one more problem to complete for this section, and it is an example of a real-world application. It says that the width of a living room is x plus 4 feet. The length of the room is 3x plus 5 feet. What is the area of the room in square feet? Please keep in mind that we want to use the area formula, which is length times width for a rectangle, and we will plug in what we know about the length and width. The length is 3x plus 5. The width was x plus 4. We now have a binomial times a binomial. Please go ahead and solve this problem, and when you're ready, we'll check the answer together. Okay, by now you should have had an opportunity to solve this problem using the FOIL process. So the first thing you should have done is 3x times x to get 3x squared. Then we want our outers. 3x times 4 gives us 12x. Inners, 5 times x gives us 5x. And the lasts are 5 times 4, which gives us 20. Combining like terms, we will see that the area for this room can be represented by the expression 3x squared plus 17x plus 20 square feet. If you have any questions about any of the problems that we solved in this section, please feel free to shoot me an email or contact me, and I will be more than happy to set up a time to work with you in our tutoring room and help you with anything that you need help with. Thank you.